We've been working with TypeScript's top and bottom types, which are any and never, respectively, in a few different ways today. So let's dig a little bit deeper into this topic and give it some proper attention. We'll look at how we can pass private or unknown values through a piece of TypeScript code. We'll look at exhaustive conditionals. And finally, we'll take a look at all of the various kinds of type guards we can build and use that can be used with conditionals to narrow a type down so you can get something more specific. So let's open up our notes to number 6, guards and extreme types. So first, let's take a look at top types. TypeScript actually has 2 of these, although one is a relatively recent development. Any, of course, is a top type, but TypeScript also has a type called unknown. Like any, unknown can receive any value. You could assign it to a string or to a number, whatever you want. The difference between these two is apparent when we look at how you can access things off of these 2 values. So for the any, you can see that we're able to grab foo.bar.baz. We're treating it like it's a nested object, and there is no type checking error there. And this is, you're playing by JavaScript rules, right? No type checking. Unknown, while it is very happy to hold any value, you cannot use unknown directly. You must narrow it in some way before you use it. A good example of where you might want to make use of this is an API response, where you know you got some JSON back, but you need to perform some sort of assertion to make sure it really is what you hope it is before you continue down that path. And we'll look at how you narrow that down, and it's through using type guards. And we'll see that it can hold anything you want, but we got to do something before we can access it. In terms of when you might want to use any, they're great for parts of our programs where we want to retain a lot of flexibility. So in this example, we can see that this function, it just is interested in printing the resolved value of a promise out to a console, right? So all it does is it waits for a promise, grabs the resolved value, and passes it to console.log. And if we look at the type of console.log, it turns out, this is the interesting one. Well, I guess they're similar here. They both take any's, right? That's what you're passing to console.log. You can pass it functions and classes, and it has its own way of serializing things out. So there's no reason for us to further limit what kind of promise we can handle in this way. Any is absolutely the appropriate type to use in this case. In terms of when we want to use unknowns, they're good for values that are either private, where maybe you have a library and you pass a value to somebody and they might pass it somewhere else, but you don't want them to know the structure of this thing. Not for like a security reason, but maybe you don't want them to depend on the structure of this thing. You don't want that to become part of your public API, right? So an example of this might be whatever set timeout returns. Like, do you really care that that's a number? It's a number because you pass a number back to clear timeout, right? So you can say set timeout, in 5 seconds invoke this function. And it's almost like it gives you a little ticket that you can use to cancel that later on. But the fact that it's a number is not really important to you. And maybe if this were a part of a library, the author would want the freedom to be able to change this to some other thing and to not consider that a breaking change. So that would be a great use of unknown. But we can certainly see that as is, they're not really usable. So what we need is a type guard in order to sufficiently narrow this type and to be able to use it. Here are 2 that you'll already be familiar with because they have meaning in the JavaScript world. Type of, inside here, my unknown is of type string. So out here, it's unknown. In here, it's a string. And so string.split works fine. Instance of promise, right? Out here it's unknown. In here, it's a promise any. So this would be how you'd sort of get it to something usable. We can even define our own type guards. So this is referred to as a user-defined type guard. And if we look at the implementation here, what type does this return? So it's like, what's this type here? Type of something equals string. It's a Boolean, right? Type of, if we were to capture that value, it's a Boolean. And a Boolean ANDed with another Boolean, it's going to give us a Boolean. So the return here, we're definitely returning a Boolean, but we have indicated to the TypeScript compiler that it should regard the true or false value of this Boolean as an indication of whether X is of type has email. And that allows us down here to use it just like we're using type of and instance of in the previous examples. We can use it to narrow from an unknown down to a has email. These are super, super handy, right? This is where your own custom types that you have in your app, you can create nice guards that will allow you to handle, specific cases. This is my favorite guard. I use it all over the place. Is defined. And we're bringing back generics here. So here's why. We have a type parameter t. We take an argument which could be t or undefined, and we return whether the arg is t. So we're trying to remove the possibility that it is undefined. And if we look at the return here, that is going to give us the correct Boolean value if we're trying to figure out that this is a non-undefined value. This value is defined. The reason I do things this way is because if I were to pass this a value that could be a string but could also be undefined, when the type checking matches that up, it's kind of like it does this. It almost lines things up this way, and so t becomes string. So this is how I'm able to kind of pluck out the undefined. The argument I pass in has its undefined value removed. And this is useful if you have a list of things like this. Right, so this is an array of type string or undefined. List, filter, filtered, we've removed all of the undefined values, and we've removed undefined from the type as well. So it's great if you have a collection, and say you have some optional value on a type, and you have an array of them, you can just attempt to pluck all of them off, filter out all of the undefined values, things just work. I wonder if they fix this. So this, actually I think this is doing exactly what it should be, but the fact that string can have a falsy value means that an empty string passes through the Boolean constructor as false, which is why we can't really tell the difference between an empty string and a Boolean. They both will give the same truthy-falsy check. But it's really, really useful, is defined, when used in conjunction with filtering functions. When working with unknowns, going back to that topic for a moment, there's one thing about this that kind of bugs me. And that is illustrated by this example. So we have a value AA, which is unknown, BB, another unknown, but a completely different type. And it's actually, like, we're not getting a type error here. So any unknown can be assigned to any other unknown. It's because it's a top type. It's just like an any. It's sort of an opaque any, We can't see into it, but it can hold whatever it wants. So it's very easy to get a couple different sort of opaque values mixed up and interchanged with each other. So I'm going to give you an alternate solution that for me is it's a little more involved, but the idea is a lot safer and a lot more intuitive. And this is called branded types. So I'm just going to create an interface that has a special property name that is very unlikely to overlap with anything any other object might have. And I have a function called brand and unbrand. What I'm doing here is, typically this would be unsafe, right? This is called casting, and it is where you're forcing a value to be regarded as a particular type. So I'm passing a string in here, and I'm forcing it to a top type, unknown, or you could do any here, and then forcing it to branded A. If we did not do this intermediate step, we'd be yelled at because there's no overlap between these types. We're making a string look to TypeScript like an object with this special property on it. And then we have another matching function that does the inverse transform. So we can pass these things around, and they don't look like strings. Nobody's ever going to be able to use this like a string. Here's the advantage. So number one, I want to make sure we agree it's opaque, right? We don't see that this is a string. We can't do string stuff with it. But if we had another type, and this is just the same thing, just a different property key and value, we can create branded values, right? The branded B takes an object with a property called ABC, just to illustrate you can do this with whatever type you want. But this is the appealing part. Because these are two different branded types with two different properties, here this one ends with A, this one ends with B, you can never get them confused. They're two different structures. There will not be a structural match between these. So we've hidden away the original identity of what this value is. We've made it so that they're not interchangeable. You can't accidentally mix the unbranding functions, which will recover the original value. But you can get back to your original values through the unbrand if you do it correctly. So it's almost like taking a value and putting it in an envelope and packaging it up. And it's like those envelopes you'd mail an important document in where you can't see the contents, but it sort of has a stamp on it so you know, like, this came from that person and only they can open it back up again. So I'll get to your question in a second. My only tip here is make sure that there's only one place in your code where you're doing your branding and your unbranding. That is the way you can be absolutely sure nobody's peeking inside this thing or accessing, trying to access its original value. Having the cast in one direction to the opaque structure and back in the same JavaScript module, that allows you to, if you wanted to change things up, you could remove this property key and, you could make changes in one location, and because nobody else can interact with it in a meaningful way, you shouldn't have to alter much of anything else. Did you have a question?
Yeah, what is the point of doing it this way versus using an object and doing a private inside of it?
Privates can only be used on class instances.
Okay, so this was...
So, you could do things that way, but that would mean that the class would have to expose a way of getting that original value back out. So I use this in particular for ID generation, or if I've got a dozen different type of entities in my app and I'm issuing IDs and I want to make sure they're all coming from my ID generator. It's not just any string, it's this. Now, I would create a branded type so you can be sure, this is the origin. It's the only function in the whole app that returns a type with this structure. When it comes time to serialize this all out to JSON, this here is a lie. It's really, this is the real type underneath. And whenever all of the types compile away, your code will run exactly as it would otherwise run. But this is just a way of saying, hands off this thing. Like, I'm going to use the type system as a way to hide the nature of this value from anyone who would care to try to poke at it. And again, it's not about security. It's about discouraging developers from intertwining themselves with private parts of your code. As a library author, I want to make sure that I can cut new releases with changes to my code, and I'm not going to break a lot of other people. And this is a way of sort of drawing a clean line, like, don't use this. I'm deliberately making it difficult. So those are top types. They can hold any values. Let's look at bottom types. So here's a never. Never and all bottom types can hold no values. And a common place you'll see this is narrowing exhaustively. So we've got a value x, and we're regarding it as a string or a number. I just have to cast here because the compiler is too clever. It's going to, even if I tried to make it a string or a number, it would say, that's a string. Like, you've initialized it. But that's all I'm trying to get here. So I have one condition here for the string case, one condition here for the number case, and you can see here x is a string, here x is a number, and down here x is a never. There's nothing left. This is TypeScript telling you that if you've been good about your types, you can never get here. So that's where you might encounter one. You're not going to be creating values of type never, but this is where you'll see one. So this is the same example, but we're going to see if we can use never to our favor. And for this, I'm going to create a new type of error. I'm going to subclass error, and we'll call this unreachable error. And it's going to take a never as an argument. The only thing that can type check against that never argument is a value of type never. That's what it means to be a bottom type. A string won't match it, a number won't match it. And then, of course, we take a message and we kind of pass it along after doing some string interpolation. So same example as we just had above, except I've just changed this to a number. Doesn't really affect anything. So we've got our string case, our number case. Down here, y is a never. Here's where this starts to get cool. If I add to this variable the possibility that it could be a Boolean, we get a type error down here. So in creating this subclass of error and in trying to take y and ensure that it is a never down at that last else clause, I am effectively asserting that all of the conditions, all of the possibilities are already taken care of. Y should be a never by this point. So this would alert me if I had a big, like intersection type like this, and I start adding possibilities to it, adding new things that this could be. This at compile time is telling me, now you have unhandled cases. You got to go in and add something like this. And now we're okay again, because now down here, y is back to never again. This is what we call an exhaustive switch. Or an exhaustive conditional, and it works equally well with if, else, and with case switch. It ensures that we handle everything before we reach that last clause. In a case switch, you would put this in your default clause, right? This is another thing that is in almost every TypeScript app that I write. Unreachable error. That and is defined. That's, if I was on a desert island and you gave me only a couple TypeScript functions, these would be high on the list. Yes?
So wouldn't it just not compile so it would never get into unreachable error? Because y is... Yeah, so
Excellent question.
How do you get into unreachable error?
Excellent question. There are a couple ways. One, you could have done some casting. You could have weakened your types in such a way that they're lying to you. And you could end up there. Just because TypeScript at that point of code says this is an array of strings, that like shenanigans that were done elsewhere in your program can make it so that's not really an array of strings. So that's one way. Another way, especially if you're writing a library, you will have consumers that are not necessarily using your type information. So if I had this in a function and I was taking y as an argument, there's nothing stopping someone from passing a Boolean in, or an array, or whatever. Remember, TypeScript's a compile time only thing, and it's not doing these checks at runtime. So by the time you make your built version of something and start going, like, all of that checking is not present anymore. That took me a while, to be honest, when I first started using TypeScript, to be able to delineate between, is this a runtime type checking thing or a compile time type checking thing? Another one is HTTP responses. I would love to be able to type check those as they come in, but TypeScript's not there anymore. So no matter what you do, there's the possibility of that stuff leaking in, which is why when we look at these type guards, like is defined, which we were looking at before, we want to make sure that the implementation of that function is the runtime equivalent of the type guard that we wish to create, right? That type of X is not undefined. That lines up very nicely. But you could have a type guard that's not quite right, and that would very easily allow you to reach this. And that's exactly where you want an exception to be thrown so that you can go and address that and track down how you could have gotten there.
Right. So it's kind of like, in the environment of my TypeScript compilation, like, this is never going to happen. But if we bundle it up, throw it out there in the wild, like, it could, so that's the case where we're going to throw the error.
You're on the right path. I would only soften it. Like, TypeScript is telling you it's never going to happen as long as you've been totally honest about your types. The type information for all libraries you depend on is perfect. Your type guards are implemented in a totally correct way. And some of these are really hard to get 100% check marks on. But let's compare it to an alternative. And let me remove this Boolean. Let's compare it to something else. Like, if we just intended to handle strings and numbers, we could have just done this. But you're never going to find out about these little incongruities. And you want to know that they're there so you can go and address them. It's something that, according to the types, should never happen. But in practice, it happens. And you want to leave yourself some breadcrumbs. I would call this here, this is almost as great a JavaScript sin as an empty catch clause in a try catch. You're swallowing a type error, potentially. Because here, doesn't matter. I could add whatever I want. No clues anywhere. This is going to fall straight through. So it's nice to have an exhaustive switch. And this is for languages that feature a high amount of safety, like Rust. They have exhaustive switches and exhaustive conditionals built right into the programming language. So it's really nice to have this feature in a JavaScript